Okay, let's get started. Some more people will join, but let's get started anyway. Good to see many of you here. Many familiar faces, but also people for whom this is perhaps the first time you attend one of our webinars. Um, I guess it's because AI is in the title. I mean, many people are interested. What are the opportunities? It's still unknown to many people, unknown to everybody what AI will exactly bring us. That's hard to foresee. If you have any questions, please put them in the chat. And Bas, who is a colleague who's here in the join with us today, he will take a look at them, and we will, unless it's something urgent, I will try to answer them at the end. Yes, it will take around, I guess, 45 minutes, but of course that will also depend on questions that come in, etc. Okay, it's good to see that we've reached 100 people in this call. Okay, so that is also a great moment to start. My name is Ger Koole. I am the science lead of CCmath with a mathematics background, also working at a local university here in Amsterdam. And in our tooling, we combine more traditional tools like Erlang and also machine learning, AI, more modern tooling. We look at what is appropriate and we use what we think is the best solution, often combined with our own insights into call centers. And that's also what we're going to talk about today. Erlang, more traditional tooling, although the way we use it, we gave it, I guess, a modern twist. But AI and how should you do staffing? Okay, let's make the problem right away clear. And this is what we're going to. Well, a central problem that many of you might have, especially if you do long-term capacity planning. What you see here, you see the actuals for a number of weeks, 5 weeks. You see volume, average handling times. Workforce, I've called this net workforce. That's terminology, we use perhaps as well. So this is without a shrinkage in number of hours. These are the opening hours, and these are the actuals. Yes, these are measured service level, also workforce. That is what you, after perhaps real-time management, that's what you use. You see a service level and also abandonments. Yes, and our common question, well, perhaps not for week 6, but perhaps for the next year, the next coming year. You have similar question, but let's say for the next week. Our forecast, there's a forecaster, a forecasting department, a forecast of 12,000. Let's say the average handling time, that's also forecasted here at 315, a bit more than 5 minutes. You want to reach 80% service level and not more than 5% abandonments. Again, opening hours, 60 hours during the week. How many agents should I staff? Yes, and of course, the methodological question is, what is the type of technology? Which method should I use for that? Yes, and of course, especially in capacity planning and long-term planning, this is a common problem. Okay, this is an excerpt of from what we just saw. So a common method is what some call the ratio method. Yes. You say you add the workforce proportionally. Yes. So, and let's have a look at that. So here from week 5 to week 6, yes, your volume is 23% higher. So the question is, okay, should I also add 23% to my workforce? Well, the service level here in week 5 was 75%, and now we want to reach 80% service level. So, okay, we not only want to have a higher volume, but we also want to have a higher service level. Yes. So we probably want to add more than 23%. But how much? Yes. And if you just look at higher volume, yes, then 10% more volume, approximately, you need 10% more workforce. So that is a straight line. Linearity is, well, not exactly. There are a bit economies of scale, but perhaps it's not 10%, but 9%. But that is, well, not that linear is not that strange. Yeah, it's not that bad. But here, to go from 75% to 80%, it's definitely not the case. 5% more service level, 5% more workforce. Yes, this is definitely not linear. So these ratios can help you. Well, it doesn't work that bad. If service level was quite good, then this kind of works. But definitely, if service levels are different, this is not that accurate. Yes. Okay. So what could you do? Well, of course, you could use Erlang. Yes. Well, for Erlang, we have abandonments. Yeah, so that means that customers, well, have certain patience that might expire. In our tooling, we call this tooling that does this in Erlang. We call that Erlang-X. Then you need the average patience. Yes, that's something that there are certain methods to calculate that, but that is one thing. You would need that to use Erlang here. Yeah. But more importantly than what exactly this average patience is that 5 or 10 minutes. What's more important is, okay, if we use Erlang here on week 6, how confident are we that Erlang gives the right answers? Yes. Well, we would have lots of confidence in Erlang if applied to week 5, we could reproduce the 75%. Because with these numbers, if we would get here 85%, then of course we know that Erlang is not working well and we don't want to apply it here. Yes, so that's something we're going to look into. Another approach, and that is of course, well, perhaps a more modern approach if you want. And nowadays, many people are, of course, trained in artificial intelligence, and especially the area of machine learning, which is that part of AI that is really focused on predictions, and actually the most successful part of AI nowadays. And then you could take another approach. Yes, instead of Erlang, you can say, okay, can I somehow find the pattern? Yes, can I train, as they call it, my machine learning model, such that I give the input of weeks 1 up to 5 and probably more weeks, and I learn the pattern, I learn the relation between the volume here, yes, and the other input, average handling time, our work hours, perhaps even more features, as they call it. And can I then predict the service level? And if I can do that, I can also apply this to my new data. Yes. So instead of Erlang, you might want to say, can we train? That's terminology that's used. Can I train some AI algorithm on, well, volume, average handling time, and this workforce in terms of hours, and have train it to give the right service level as output. And so these are the 3 methods. I think because of this here, it's clear that the ratios is, that's, well, perhaps the first thing you try, but we need something more advanced. And so, as I said, we have, well, in principle, 2 choices, old-fashioned Erlang. And nowadays, with the advent of AI, we could also train a machine learning model. So let's have a look at them, and let's first have a look at Erlang. Okay, so what did I do? And I don't have time to go into all the details about how to use Erlang exactly. I mean, there are other, we have multiple webinars on our website, and where you can have a look at that. And we also have trainings if you want to dive deeper into this. But what did I do? I took the data from these 5 weeks, yes, and I just applied Erlang-X. So that is the traditional Erlang C, but here we have all the additional feature of abandonments. Yes, and here in the formula, you can see the formula here, how it's applied. So you start with volume. Of course, this volume, this is I want to have it per average per minute. Yes, of course, in a week, Monday early morning, there's less traffic than in the middle of the morning, etc. But you can apply Erlang to like the average minute during a week. So as you can see here, volume divided by the opening hours divided by the number of minutes in an hour. Average handling time is seconds divided by 60 in minutes. The net workforce divided by the opening hours. 1/3 is 20 seconds in minutes. So that's the time. That's the time to answer. The waiting time target in your service level calculation, the 20 of the 80/20, 1,000 lines. This is you can give the number of lines, but set it to a high number because that's not really an issue. Here is the patience. I just set it to 5 to take a number, not super relevant. No readouts. That's also something related to forecasting. And the 2 here, that said something about the service level definition. So service level definition is on offered load, so including a balance. Yes, but the important thing here is whether or not this is perhaps this went a bit fast, but the important thing is that our Erlang formula predicts here an 85% service level, while the actual service level was 72. And as you can see here, there is a systematic difference. There's an error. There's a bias. And so apparently, Erlang here overestimates the service level. Yeah. Okay, how can this be? Yes, and we entered the right numbers. We entered the volume, the average handling time. This was the actual number of hours that you use. So what's wrong here? What could explain these differences? Well, let's look at 2 important. I'm not saying that this is the full list, but there are at least 2 good reasons, except for perhaps errors in your data or you're not measuring certain shrinkage factors. That could be reasons. But even if you do everything right, then still this can well be the case. And actually, this is also what we encountered in a number of call centers. We see this happening. So what could be the reasons? By the way, these numbers are representative, but I've made up these numbers, of course, also because of privacy reasons. But yes, but these are definitely representative. Well, the first thing is what we call shift inefficiencies. And that has to do with the fact that, of course, with your workforce, you try to follow the workload. Yes, to make sure that you have a good service level every hour of the day. Unfortunately, that's not always possible. Yeah? So that means that that sometimes you're a bit understaffed, sometimes you're a bit overstaffed. So here I have an example, super simple, just 2 intervals, just to illustrate my point. Yes, I have 2 intervals, but in the first interval, I'm overstaffed. I have a 94% service level. Yes, in the second interval, I'm understaffed. Yes, so using these 2 intervals, I can calculate the service level for the 2 intervals combined. And of course, if you take more intervals for the whole day or the whole week. Of course, this is a weighted average. There are more customers arriving in interval 2 than in interval 1. Yeah? And then you get to 61%. Now you do the Erlang calculation on the average. Yes, so the average of 2 and 10 is 6, etc. Yes, average number of agents. Then you get to 71%. Yes. So apparently, yes, if there's an imbalance between workloads and workforce, and you do the calculation of the whole day or week together, yes, Erlang overestimates the actual service level and underestimates. Of course, less abandonments is better. The abandonment percentage. Yes. So And that always happens, these shift inefficiencies, because you cannot match for 100% the workload with the workforce. Yeah? There's always hopefully a slight unbalance. So that explains, that might well explain part of the difference. Another reason is the following. Yes, what I did here, and sorry, it's a bit small, but I'll show you the numbers in a second. What I did here, perhaps you have a multi-skill call center, but you do your calculations on everything aggregated. Yes. Now, Erlang, in principle, only works for a single skill. Yes. And for multiple skills, well, there's no equivalent of Erlang. So then you have to simulate. Again, I don't expect you to understand all this. This is a completely separate subject itself. But what I did here, yes, what I have two queues, and I have a number of single skill agents for Q1, skill one, a number for skill two, and a number of multi-skilled agents. And the service levels are down here. So I copied them in this Excel sheet. So 19 agents for skill one, 13 agents for skill two, and 5 multi-skilled agents. Yes, and this is the simulation. These are the service level. Again, the average, weighted average again, because there are more calls arriving in Q1 than in Q2. And now we do the Erlang, and then we do just as if everybody is multi-skilled. Then again, you get a higher service level. Yes, of course. Yeah. Here it can happen that there's a call waiting in Q1, but there's nobody with skill one available. Otherwise, the call wouldn't be waiting. But there are agents here available who have skill two, but not skill one. Yeah, so that's less efficient than with everybody multi-skilled. Of course, there are good reasons not to have that. Yes, and often it's impossible. Yes, but that is what the Erlang calculation does. So here you see also a difference. Yeah, so that's second reason why this bias, this systematic difference, that could be a reason for that, is that you're a bit less efficient because not everybody is multi-skilled. Yes. Okay, so these are two reasons, going back to what we saw earlier, why Erlang might be wrong. Okay. Later on, we'll see how to repair that. But now let's look at, given the fact that Erlang might be biased, okay, what could we do? Okay, so what we see is this new approach using machine learning. Yeah? So the idea is not to use Erlang. And typically, a data scientist with a computer science or AI background usually doesn't know about Erlang. That's more a mathematical thing. Yeah, well, I see your question. I can answer it. What if you have priority scaling for multi-skilled agent? Yeah, you can twist it a bit, and perhaps it gets more efficient, but there will always be a small difference. Also, if you have more multi-skilled agents, it might be that this difference is smaller. Yeah. And an interesting thing is, actually, and we'll get to that, how can you use the things that we're going to discuss to evaluate this? Yeah, so I think it's important. Yes, this 5%, perhaps you say, hey, this is too big. I want to have it, this is too costly. So I train more multi-skilled agents. Yeah, or less expensive. First, I'm going to change my routing to make my skill-based routing better. Yeah, so that is very relevant. And then hopefully this difference between multi-skilled and single-skilled will get smaller, and these inefficiencies will partly disappear. Yeah, so that is definitely an option. And then this difference won't be 5% as in this example, but perhaps 3 or something like that. Yeah. Machine learning. Okay, so what would be more an AI solution and a less mathematical solution? Okay, so super simple. With the example that I've been showing you, you take you want to reproduce the surface level. Yes, and that is a function that depends on the volume and the workforce. Yes, so you want to train, as we call it, a machine learning model, where you give as input for a number of weeks, in our case, volume and workforce. The average handling time doesn't change much. We could do that as well, but let's not make it more important. I'm going to focus on the surface level. Yeah. And the nice thing about it, it doesn't have this systematic error, this bias that we had with Erlang. Yeah. And in principle, these machine learning methods, they can find any pattern. Yes, that is what they are very strong at. Yes, that's that they can. You don't know the pattern, you don't have to give it up front. Yes, it will find in principle any pattern. So let me show you. Yes, and again, I guess most of you, perhaps there are a few computer scientists, AI people in the audience. Let me show you a bit how this looks like. Again, I don't expect you to understand it, but I just want to show you how that looks like. So what did I do? What you see now is a bit of Python code that I actually made. I'm not somebody who programs these type of things daily, so I had some some Gen AI tooling help me in setting some of these things up. Yes. So what you see here is Python code. Yeah, so Python is a programming language, probably heard of it. Many people are using that. Many data scientists are using that. And here you see a link to a Google Doc, which is actually this Google Doc. So this is the input we had. Now I put it in some Google spreadsheet. So here you see the volume of these weeks, this workforce, and here you see the service level. If you remember, it was 72%, etc. Yes. So what am I doing here? I am loading certain libraries to have all kinds of algorithms available. I'm loading this document. I am, putting this document in the right, to prepare it to use it for some AI model. And actually, this is where the AI model is being called. Yeah, it's an AI model. Again, cannot go into all the details on what types of algorithms exist, but this is a random forest. That's a type of machine learning algorithm based on decision trees. Again, I don't expect you to understand all that. Yes, but what is important, this is an algorithm that can match, in this case, volume and workforce to surface level. Okay, now let's run it. I already ran it, so the output is here, but now I'm running it. Let's do it again. Takes a bit of time, actually. It's not even the algorithm, it's all the connection within. As you might see, this is a Google Colab. So this is free software offered by Google. Everybody can use that. If you know about the programming, of course. What we see here, this is the output. This is, I asked it first to print, where is it? Here, to print the data. So here you see the data again, now it's columns. And then I made, you cannot tell, okay, for 12,000, I want the 80% service level, but you can try different workforces and then get the output. And then get the service level. So I tried different workforces, 1,100, 1,200, 1,300, for workload, for volume, number of calls forecast, 12,000, the one we were interested in for week 6. And what do we see? We get 3 times 70% or 69, 77. And if you think about this is weird. Yes, and for those of you who are computer scientists in the audience, this is indeed a small example. Perhaps this isn't the best algorithm. If I were to use this in practice, I wouldn't do it exactly this way. It's to illustrate the point. And if you disagree with the point, you can say that later on. But it's to illustrate. Yeah, I know there are only 5 data points. But however, these methods were good for many data points. But sometimes you only have 10 or 20 weeks. So that is. So in that sense, yes, you only have 5 data points. Yeah. But the thing here is, as you can see, uh, well, I increase my workforce, and then I expect, of course, that my service level goes up. And what do I see? I increase my workforce, and my service level doesn't go up. Yeah? So why is that the case? Well, and what is the reason behind this? Is that there is no, in this model, there is no logic. There is not the type of pattern that we know that exists in a call center is not within that model. Yes. So apparently something, so you can say this is the downside, instead of, so the call center logic that you would expect is not in here. Yes. So and let's go back to the presentation. So how to deal with that? Yeah. So this is what we saw. Yes, this is the output we just got. Yeah. So what did we see? Well, we have had advantages, and I repeat them. There is no systematic error like you get in a white box model, which is Erlang. Yes, and it can, in principle, learn any pattern. Yeah? And if you give it enough data. However, there are also disadvantages to this machine learning approach. In the first place, and that's a very common problem with these models, it is a black box. Yes, meaning that you do not understand what's happening. In an Erlang model, there is a logic behind it that tells you, okay, if I increase my volume, my service level goes up. Yes. And it's a big issue within AI, and of course there is some tooling to get around this. Yes, but this is one of the big disadvantages of this type of tooling. It is a black box. And there's something else. In AI, this is known under the term of generalizability. Yes, is indeed, and of course, I gave the AI a difficult task because the 12,000 is well outside the range of the first 5 weeks. Yes, so you ask it, how can it learn something for which you didn't give it examples? Yes, I gave it examples in the range of 10,000, and now I'm asking, hey, about 12,000. Yeah, it's like I gave it all kinds of English phrases, and then I asked it to speak German. Yes, that's also impossible. Yeah. And so that is commonly known in AI as a problem of generalizability. Yes, how can you generalize to something that is like outside the space in which you learn? Yeah, and that makes this type of model less robust, less trustworthy, because, well, and perhaps you're asking something that it hasn't been trained on. Yeah, and that is exactly here. This AI doesn't know, what to do with 12,000. Doesn't know if it's there. You didn't put upfront some linearity or some other form in it. And what Erlang does, it puts upfront this type of form in it. Okay, so what to do with that? Yes, how can we get around this issue? Yes, so we had 3 approaches. We had ratios, and we saw that ratios cannot handle the service level issues. We had Erlang, we saw it had a systematic bias, and we have plain vanilla machine learning, it has generalizability problems. Yeah? Now, if you listen well to experienced machine learning people, they will all tell you, okay, these algorithms are nice, but what is really important is understand the domain in which you're working, domain knowledge, yeah? Understand what are the right features. And this is also here the case. It is understanding what is underlying and coming up with an approach that kind of combines the two. Yes, and what is important here is that we need to use this understanding that if you increase workforce, yes, that your service level will increase. Yeah? So the approach that I am putting forward here for this type of problems is is a hybrid approach. I've called it Erlang machine learning. Yes, the machine learning in it is that we are actually tuning some parameters. Yes? So how does it work? Yes, so we still use Erlang. So we still understand, and we still know that it behaves in the right way. Yes, by using Erlang, we know if we increase workforce, service level will go up, etc. Yes. But we know there are these inefficiencies. Yeah, I've discussed with you these inefficiencies that can come from the match of the workforce and the workloads that might come from the fact that not everybody is multi-skilled. Yes. So we know there is a certain level of inefficiency, but we do not know at this level. And second, what we often do not know is the average patient. Yes. Now we have two outputs. We have service level and abandonments. So what we can do is we can change, and I will do so by hand, but you can also put some algorithm behind it, some learning algorithm. So that is the machine learning part of it. You can also put a learning algorithm behind it that combines, that learns what are the inefficiencies and what is the average patient. Okay, so, and I'll go to Erlang and illustrate this to Excel and illustrate it for you how this works. What is important to mention is that you assume that these inefficiencies stay the same. Yeah? Of course, you assume that the future will be, well, as the past. Yes? Otherwise, if the future is different because you reorganize fully your skill-based routing, for example, as has been suggested, then of course you get a different level of inefficiencies and you cannot trust the past anymore. Yes? But so let me go to Excel and let me show you how that works. This one. So you can see, you can see Excel right now. Okay, so these were the original. So this was the calculation I showed you before. Yes, and as you can see, using these numbers and an average patience of 5 minutes. But now I want to again have this number. Well, this is too high because my actual was 72%. So I want to get it down. Yeah, so we started actually with a patience of 5 and inefficiencies of 0%. Yeah? And now you see I have exactly the same numbers, same workforce. So what I did here I have, this is my patience that I'm going to use for all the weeks. So I assume that the patience and also the level of inefficiency stays the same. And now I want to fit, and again, I'm going to do it by hand, and I already tried this before, so I know what the outcome is. You can see that in the PowerPoint, but you just saw it. But okay, well, I have a too high service level, so apparently there are some level of inefficiencies. By the way, this is our Erlang X, and it takes a second to do the calculation because it makes connection with our online servers. So I can adapt, and of course, if I increase the inefficiencies, you see the equivalent workforce going down here from 1160 to 1105, 5% less. And by tweaking a bit, yes, and again, you could use an algorithm for that. I think it was, what was it? I think a good answer was 10 minutes on average patients and 7% inefficiencies. And now you see that it's actually a pretty good match. And actually what we did was now doing the backwards calculation. So now I'm interested in 80%. Actually, you could have calculated also the abandonments, but they will be below 5%, something to check, of course. But I'm looking for the 80%. Then I'm doing a backward calculation. I'm calculating the formula here, the number of agents given a certain service level. So that is 1249. And then I'm adding the 7%, that the inefficiencies to come to the net workforce that I really need ready to take calls in this particular week. Yeah. So the point here is, on one hand, using the form, the proven form of Erlang, but using a fitting procedure. Again, it's not a super sophisticated algorithm, but the machine learning, the training comes from the fact that you fit these patients and these inefficiencies. Yes. By the way, this gives you also very interesting insights. Yeah, it gives you the idea that the average patient is around 10 minutes, and many people think that callers are way less patient than they are in reality, because you only see those who abandon, and these are, of course, the less patient customers. Yeah, but also interesting is to see these inefficiencies. So apparently, for the reasons we discussed, and two good reasons are the shift inefficiencies and the multi-skill inefficiencies. Apparently, we lose 7%. Yeah? So that would be a reason to do a deep dive into this. So this procedure also gives you insight and gives you possible ways to at least a starting point to improve your processes. Yes, perhaps you can improve your scheduling procedure to reduce your shift inefficiencies, for example. Yes. Okay, let's wrap up, and then it's time for. I saw some questions coming by, and then it's also time for questions. Bas will be moderating the questions. So let's go back to the presentation. So to wrap up. Okay, so actually here it's in percentages. Didn't show that yet. So the volume increased with 22.7%, 23 rounded, as I showed you earlier. Now, because the bigger the call center, the more economies of scale, you expect that when you add 22.7% in workforce, you add a little less. But actually, because you also want to go from 74.7 to 80, you add a bit more. So let's say that perhaps 22 or 22 something is added because of the higher workloads, and then you add another, 2%, go from 75 to 80. That is the conclusion. Okay, let's wrap up. So, as we saw, a disadvantage of Erlang is that it might have this bias. Yeah, Erlang is based on understanding how a call center works from the inside, but it's a white box model, as we say sometimes. But you cannot put all the features of a call center inside and not the full behavior. Of course, a machine learning model can try to mimic this behavior, but it is, and that's often said also about Gen AI, there's no real understanding at the inside. And here that means that, the crucial behavior of this call center. I'm not saying it cannot be repeated. If you give it enough data, and if you have enough historical data, and if you give it, and if it's not such an outlier like the 12,000, yes, then it might give you good results. But you're not 100% sure, and there's no explanation behind it because it's a black box. Yeah, so that gives always a bit of uncertainty about how good is it. Well, if you're using Gen AI, sometimes it gives you a bad answer, but you're there to check the email and to see if it does it right. Yes, but here, it's hard to check. Yes, so there, and it's well, that is more difficult. Yeah. So this robustness and this fact that it's a black box, that it's hard to explain what comes out of it. That is, that's an issue. Yeah. So what I proposed is kind of a hybrid approach where you do some fitting if you want machine learning. Yes, not super complicated, not a super. You could make a fancy algorithm, of course. You could perhaps even use more features for AI specialists, among the others. And so I propose is a hybrid approach. So still use Erlang, yes, but fit the patients and the inefficiencies to the actuals. For Erlang people, you could see Erlang is kind of an activation function in your model. Yes, so if you dislike this type of approach, perhaps framing it like this, you will like it. And as I said, there is a bonus, because if you use this, and this is really a white box approach, because these the fitted values, they have a real interpretation. Yes, so it's one hand the inefficiencies, and it's at the other. On the other hand, it's the patient. Yeah? So this really gives you insight in customer behavior and in the quality of your operation. So it could really be a starting point for a deep dive into the inefficiency. Okay, that's what I have to say. In 1 minute, we'll go to the questions, and I'm certain that there are lots of questions because, what we try to do is really use the best method for the problems we are at hand. But of course, there are people who are very fanatic about different methods, about the possibility of AI, and so I'm certain there will be that we can have a long discussion about this. So let's see that. Let me finish by giving you this slide. If you think, hey, this is interesting and I want to try this out. And I know that some of you already have it, but so we have this Erlang add-in that I showed you how it works in the Office Store version. You can also store it locally, then it's way faster than you do not have the delay of the internet with it. We have Python and R versions where we're making the interface with Google Docs as well. We're working on a slightly improved version that, especially for very small volumes, does some interpolation a little bit better. You can find things on our website. And also, if you're interested in trainings, we have a training agenda. You can go to our website, and soon we will also publish the training agenda for next year. And we are planning, we are going to give an AI and WFM training. What I just explained to you will be a small part of that, but we will explain what is machine learning. We will also explain, we're going to details about Gen AI. Elena Garlati, she is a CCmath employee, but she's also working on her PhD on using Gen AI for forecasting. So she is really a Gen AI expert And together we'll give this training December 1 in the afternoon, Amsterdam time. Yes, and there is a relatively small fee. It's for us. It is to get people interested in this type of tooling, and so we hope that many people will join there. There is already a form on our website. So if you go to a website and then to professional services trainings, then you already can register for this training. Okay, let's go back to the conclusion, because I think the questions will be about all this. And so Jesper just shared the link, and I'm open to any questions that you might have. Okay. Yeah, so I see one remark about by Koos about the average patient. Yes, actually there are statistical methods. So what you measure is not the patients. Yeah, so because many people, of course, they get connected. So what you measure is less than the patient. Yeah, somebody has a patience of 5 minutes, and somebody else you get connected after 3 minutes. Well, then all you know is the patience was longer than 3 minutes. Yeah, but there are statistical methods. There's the Kaplan-Meier estimator to reconstruct in a statistical way the patients. Philip, it's only, of course. Yeah, that's an interesting point. So it would be a far better model with interval data than weekly data. Yes, I agree. But if you're doing very often in capacity planning, you do not have that. Yes, but I agree with interval data, it would be much better. There's more noise in interval data because there's a lot of randomness in interval data. And so I could have used gradient boosting as well. I use random forest, which is also based on decision. But I fully agree that if you have more data, as I explained, then probably your model gets better. I hope I made it clear. This was really for illustration. The things that I showed are really there, but of course with a lot of tuning, more data, looking at interval data, hopefully it can get better. Yeah, but I think I also gave a very robust method that also works, yes, and that also gives you more insight, yeah, and that really uses understanding from call centers. Another remark about optimal routing. Yeah, of course, that it was not the main topic of today. Yes, and the point I wanted to make: if you have multi-scale operations, you always lose some efficiency. Yeah, but of course, if you do routing better, and if you have more multi-skilled agents, of course, the inefficiencies will get smaller. And I do agree that routing is something which is relatively easy, relatively cheap. You do not have to hire new agents. Yes, but I think it's so I think it's something we should look more into. I see if ease of understanding and explaining the forecast is critical. Yeah, it's always the definition critical. What's the forecast? What's the prediction? So with forecast, I always talk about volume or if it's handling time, and with the prediction, the service level prediction. So the ratio model, I think that's the simplest model. Yeah, but I think that lacks a bit the complexity if you have different service levels. But if even your historical data, the service level was right, then often simple ratios work. It all depends how complex is your call center, what works for you, does it give reliable results. On the other hand, I think that also the savings by having a better forecast or a better prediction are often overlooked. If you do, together with Bas, who's also here today, we looked into potential savings by making by making a better forecast, and they can really be substantial, in our opinion. So having a better prediction, only if it's by a few percent, having to do less real-time management, needing less flexibility, having a more stable workloads. It's if that is also, it adds, it's good for everybody. Yeah, it makes agents happier. It's if you have a stable service level, it makes your customers happier. And that had lots of consequences also in terms of churn, both customers or agents leaving. So lots of advantages to that. Okay, interesting question. How do your model work when there's a mix of inbound and outbound? If you have inbound and outbound, then you're blending, or if it's outbound or perhaps emails, if you're blending different types of activities. So you should use other tooling for that. But I think, I haven't tried it out yet, actually, but I think similar methods apply. We do have tooling for blending as well. So next to Erlang-X, which is typically inbound, we also have a variant for blending. And again, I never tried it on real data to see how good it works, but that should work as well. Yeah, and if you're ever interested in trying, let us. Yeah. So Bill, the modified Erlang, as you call it, appears far easier to explain. Shifting requirement. Yeah, using that's typically the black box effect. The model said something. That's also the case with forecasting. Today's focus was, of course, on predictions, not on forecasting. But the same holds for forecasting. Also, there are the same similar methods, like this random forest or gradient boosting, as somebody mentioned, are commonly used by forecasters. But the answer is a black box. And there are some methods that you can use afterwards to look at which features are most important. So there are some methods, some workarounds, but they are not as robust and as clear as, well, other types of methods in which you can say, in which you can really decompose your forecast into its different components, or a linear regression type method. Not saying it's the best method, but at least it gives you an explanation. And if you are going to tell to the call center manager, okay, next year we need 10% more agents. Why? Yeah, because my algorithm told me that the volume will be 10% higher. Of course, you want a reason behind it. And again, I'm not saying it's impossible, but it is difficult, and the same holds here. Okay, I'm going to look at black box methodologies are another remark. I think, well, it's a risk if you use. That's why I'm using the word robust here. I think we're looking for robust methods where you cannot have complete things that are illogical. That people trust. That is what you need. Yes, and that holds, unfortunately, less for AI, and it really depends on the environment if that is acceptable or not. Okay, I think I've answered most of the questions. Well, you all know how to contact us if you want to dive further. We're always very interested in learning about your challenges. And we're always very happy to talk about our products, of course. Also, if you have a challenge, let us know. Bas and I are very happy to have a chat with you and to see how we can help you, or which suggestions we can make. Thanks a lot for attending. if you want to sign up for the AI training, please do so. As I said, new training will be, our schedule will be online soon. I hope you agree that we can send you an email now and then so that we can keep you updated. It won't be that much, but I hope that's fine. And I hope to see you at some other opportunity, at the next webinar, or perhaps in a meeting. For today, thanks for joining. Really like the fact that there were so many of you, and I hope to see you soon. Thanks again. Bye-bye.